This evening, we turn the page to another astronomical season, so it's time to welcome back our resident astronomer, Dr. Chris Palma from the Penn State Department of Astronomy and Astrophysics, for one of his quarterly visits to the show. Always good to see you, Chris. So since we last talked, I saw two, which to me, very cool stories that both involve asteroids. And each has its own interesting name attached to the story. So let's start with Psyche, which I guess is both the name of a spacecraft and an asteroid.
Yes.
What's newsworthy there?
Yeah. So folks probably have heard that, right? If you think about planets, Earth has an iron core surrounded by a rocky crust. Well, what happens if you take an object out in space with an iron core and get rid of the crust? That's what we think happened to Psyche. From everything we can tell from Earth, this is a giant lump of almost pure iron orbiting the sun. And so the Psyche spacecraft is going there to determine if we are correct that this asteroid is solid metal.
Very interesting. And then the other story involves an asteroid named Bennu. An actual sample from that asteroid was returned to Earth back in late September. What have we learned so far from that sample? Because that seems really neat.
Yeah. Well, I've got to agree with you. Sample return is something really rare. But the reason we did it is, again, if you think about asteroids, over time, rocks hit the Earth. And in the past, many, many of them hit the Earth. And so the reason we grabbed the sample is to determine when those objects hit the Earth, could they have possibly delivered water? And so what we've learned so far is that the minerals on this particular asteroid are very water rich, suggesting that asteroids may have brought water to Earth.
And I suppose this sample, you know, when you think about bringing samples back, the Apollo astronauts brought back pounds and pounds and pounds of rocks. This was a tiny little sample. So I suppose folks in your business are fighting over who gets to examine it. Let's now, speaking of your department, let's talk about some research coming out of your department. You know, all the textbooks, when they show Earth's orbit around the sun, it always looks like an ellipse, so we're kind of trained to think that way. But I guess some new research in your department has to do with the shapes of orbits of planets around other stars, and it's a little bit different.
Yeah. Well, I honestly want to talk a little bit about the techniques, right? So how do we even figure that out? So what we've always seen is what we get to witness is planets passing in front of their star. And we've now been using this technique for years and years and years, and we have so much data that what I really want folks to understand is that astronomy is a very computationally intense science, very much like meteorology. We have to use supercomputers, and we have to crunch all of that data using artificial intelligence. And what we find is that it does appear that the orbits of planets in general, when you have multiple planets, appear to be very circular. So the reason we find that so interesting is what we always want to know is how did planets form? And so if you know what their orbits are like today, that lets you infer how they must have formed.
Okay. And that same line of research also suggests that our solar system is not like many of the others that we're now observing. What's different about our solar system?
Yeah. Well, you know, we think of Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. So we've found other systems that have Jupiters very close to their stars, so we call those hot Jupiters, right? We've found other systems that have rocky planets like Earth, but are much more massive, so we call those super Earths. And then we've found icy gas planets like Neptune, but that are lower mass than Neptune, so we call those sub-Neptunes. And it looks like from all these planets we've been finding, super Earths and sub-Neptunes seem to be very common. So then the question is, why don't we have one, right? We have a Neptune and we have an Earth, but we have nothing like a super Earth or sub-Neptune.
Yeah, but those folks in those systems are looking at our system and they're saying, what's wrong with their Earth and what's wrong with their Neptune?
Exactly, exactly.
And this James Webb Space Telescope, it just keeps on keeping on. This is the one that NASA put into orbit about 1 million miles away from Earth. Almost 2 years ago, just keeps producing results. I guess now it has discovered the second most distant galaxy ever observed. Tell us about that.
Well, I really think, I want to emphasize, I think our theme today, whether we said it or not, is formation, right? If you say, what do astronomers care about? We're so interested in how did the universe form, how did galaxies form, and how did the stars and planets form? Well, the reason this James Webb discovery is so exciting is we keep pushing back to further and further distances. So we're seeing these galaxies further and further back in time, and that's helping us understand how did galaxies form. So prior to James Webb, we could see galaxies relatively close to us. We have data that helps us infer what happened during the Big Bang, but this was an unknown time in the universe's history, and it's these galaxies that are really revealing it.
So it's a galaxy so far away that it's telling us more about what the universe was like close to the Big Bang.
Exactly.
How about, as always, we finish off with some sky watching tips for the next couple weeks, maybe?
Yeah, sure. Well, everybody's been asking me, what's that really bright thing I can see in the sky? And so usually the answer to what's the brightest thing is almost always going to be Venus or Jupiter. So right now, roughly in the southeastern southern sky, you're going to see Jupiter. But if you can find that, I always tell people, use that to look around. Once you've found Jupiter, look over a little bit east of that, and you'll see this really pretty star cluster called the Pleiades. And then once you can see the Pleiades, if you look closer down towards the horizon, you should see Orion's belt. And so if you've ever wondered, what is the Orion Nebula? Try to determine one of the stars hanging off of Orion's belt isn't actually a star. It's a faint, fuzzy nebula.
Okay. And this is the evening sky?
Yes.
Okay.
Yes.
Dr. Chris Palma, Penn State Department of Astronomy and Astrophysics. As always, Chris, thank you.
Thank you.
And we will be back in a moment with more.